All right. Yeah, welcome everyone to our first session of the webinar series for this year, 2026. And yeah, today we have Aurelius, who will present on UAF for sustainability planning. And yeah, the floor is yours. You can maybe do a short introduction and your background and maybe how UAF links to sustainability and get started.
Okay, thank you very much. Hello, everyone. I hope you can see my screen.
Yes.
Perfect. Okay. All right. So let me quickly introduce myself. So my name is Aurelius. I'm from primarily from Dassault System. 20 years working on software and systems engineering. I'm also working with Incozy, of course, and one of the things I recently started with Incozy is chairing the Enterprise Systems Engineering Working Group. If you haven't heard on this working group, I encourage you to get familiar and perhaps even join some sessions, especially if you are in Incozy workshop next week. Then also been working with OMG for quite a long time, leading the UAF development. It's 15 years already, and UAF is the Unified Architecture Framework, and I will talk a little bit more about it during this presentation. Other than that, I also teach in the university and specifically enterprise systems engineering. Okay, so that's me. So this work that I'm going to present specifically today has been co-authored by a couple of my colleagues. So I should give a credit to Aiste, Edita, and Very. So these are the people that helped to publish this work in a different ways that I will also mention later on. So today's agenda is the introduction. I will present what the UAF is and what is this work about, and then what kind of approach we are using for the architecture, and what case study we took to demonstrate how it can be applied towards enterprise transformation, and specifically in this case, it's towards sustainability. And then we can go to the summary and a couple of related works that has been done really quickly, so that just give you the reference so you can find it and study later on. And then I hope for some questions and discussion. Okay, so first of all, let's start from the enterprise transformation and what the enterprise transformation is. We all know that proper planning is really the key. Whatever transformation we want to achieve, it's very common to talk about digital transformation, and it's usually the primary topic. But also when it comes to sustainability, is also where we deal with the transformation. So it can be sustainability transformation, or it can be both, or it can be any kind of business transformation we can envision. So basically, even the approach that I will be talking about is kind of generic. It can be applied to any kind of enterprise transformation. And we know that for this effort, primarily the documents are used, and many organizations, many clients of ours who are going through the transformation, they really first of all focus on the documents, and it's far away from being something more the model-based approach. But what we want to show here what we want to highlight, and what also the I work on in COSI and in OMG is really to provide model-based approaches towards enterprise transformation, and how can we benefit from model-based as opposed to the documents, and how we can do it way more efficiently than by the standard means, which does not really involve a model-based environment. First of all, I wanted to clarify on some terminology so that we are aligned and we're all on the same page. It's always the hard part because we use the same words to for the different things and different meanings. So I would like to start from that. And first of all, of course, the term enterprise is especially important to clarify, as it has a slightly different meaning in different countries and different languages. So what do we mean by the enterprise? Is really a large undertaking, especially one of the large scope, complication, and risk. It is the way it is described in the COSI technical product on the definitions that I have the reference here on the slide for at the bottom. And so when I share the slides, you can navigate the link and access the technical product that has been released in 2020. So that's the latest on the definitions. And this is the definition that in COSI use, but there are different definitions which are kind of similar, such as, for example, purposeful on or industrious undertaking. So one of the highlights here that we don't put the equal sign between enterprise and organization, which is commonly done in the different languages and even the different areas and industries. And what's different when we speak about enterprise systems engineering and product systems engineering is that the enterprise systems engineering is really includes socio technical systems. So this is where we also speak about human beings being part of the system, study their interactions and how in general the enterprise and the organization behind it really change in time and evolve, and it will evolve constantly. So going a little bit deeper into the definitions that I just presented, it's in COSI presents three types of engineer systems, such as product, services, and enterprises. And in the Enterprise Systems Engineering Working Group and in COSI, we study what are those differences between the three. And in a group, we disagree that it's the same approach for all of them, because first of all, there are different methods, different tools, different languages. The people on the product development side speak the different language than the people on the enterprise development side. Plus, we have services in the middle. So service is something that is close towards enterprise, but it's somewhere, in between the product and enterprise. And then we go really from the complicated when we are on the product side to the complex, which is on the enterprise side, and going from technical towards socio-technical, which involves fuzzy requirements, a lot of risk, richness of human resources, and also the composition of services and products and how they interact with each other. When we speak about examples of the enterprises, again, it can be a company, it can be multinational corporations. So we don't say that the enterprise cannot be seen as organization. We just say that it can be more than that. It can be a program, a military program, for example, space program, some project, can be mission, again, military mission, space mission, smart city, enterprise. Then it can be seen as a kind of a global problems such as climate mitigation, energy transition, global market of supplies, global market of gold, copper, and other precious metals and minerals. And there's some examples on the right that we put for every type of the different enterprise. So this is a little bit about the terminology. What do we mean by enterprise systems engineering? And then if you would be willing to learn more and contribute, it's a little bit of promotion before we jump on the topic is the Enterprise Systems Engineering Working Group in INCOSE, the purpose of which is specifically enhance the understanding and adoption of enterprise systems engineering, and by leveraging model-based approaches and standards such as Unified Architecture Framework. Currently, we work on the 3 working items. It's the primer. So as we're a new group, we just started this March. So first of all, we want to develop the primer, which would give the basic understanding what we're speaking about. Then we're working on the ontology. That's the newly approved technical product we have, Enterprise Systems Engineering Ontology. And finally, we're trying to work on internal project where we model INCOSE enterprise, again, using Unified Architecture Framework. And we have some sessions planned in the INCOSE workshop next week. So if you are there, you are welcome to join. Okay, so now let's go to the topic. And first of all, why this topic? I will show you the research that studies the city bus transportation transformation from hybrid to fully electric. And I will show you the model developed for that is created in the Unified Architecture Framework. And why we did this research? Because we wanted to propose the approach based on some international standard like Unified Architecture Framework of applying model-based approach, and we wanted to provide some kind of the guideline of taking the standard and applying it for this specific purpose. And as we see, the standard is huge, it's complex, and we needed to we wanted to show some kind of the lighter application for the specific use case. And in this case, the enterprise transformation, sustainability transformation planning. Okay, so before we go to the case study, I would like to, because I'm not sure if all of you are familiar, but I wanted to talk a little bit about the Unified Architecture Framework. It is a standard to develop architecture descriptions in commercial industries, federal governments, and military organizations. For those in the military, if you're aware of the Department of Defense Architecture Framework or the NATO Architecture Framework, it is compatible with these defense frameworks and really it's inspired by these defense frameworks, and then turned into something that is applicable to any industries and multiple use cases. Where we identified 58 of them. This way identified in the UAF working group, in the object management group, and I will show you quickly what are those use cases where they span really from systems engineering to mission engineering, enterprise systems engineering, systems of systems, etc. And the standard is, as I mentioned, developed by the Object Management Group and is also recognized as international ISO standard, and the ISO number is 19540. The current version of the specification is 1.2, but 1.3 is really, in a way, it's finalized. It's just a couple of signatures and approvals, and it should be there by the end of February. Why do we need something like UAF? First of all, is that we want to speak the language that really architects and systems engineers understand. There are other languages such as systems modeling language or UML, the Unified Modeling Language, that speaks just some generic terms like blocks, activities, states, etc. But it's not enough for the community oriented more towards towards business operations, goal setting, and capability development. So this is where we need a specific vocabulary that the enterprise architecture, unified architecture framework provides. And at the same time, also it provides some guidelines, some organization, and really gives you some kind of tool to really start looking into the way how to model. But at the same time, when I hear the question, do we want UAF or SysML? It's not the right question, because UAF is built on SysML, and this is where you get everything that SysML has, plus you get on top the vocabulary that you can understand and that people working in this area can actually understand and apply for their specific problem solving. And UAF is methodology agnostic, so this is where methodology really depends on what is the problem we're trying to solve. And here's the number of problems that UAF can support solving. So we identified multiple use cases, going from 15288 system lifecycle processes, and actually here's a lot of work been done on the GFSC, the German chapter of INCOSE, where they recently produced a new technical product, which is the 15288 processes modeled in UAF. So it's kind of a reference model, reference architecture, so that organizations that wants to implement systems engineering process, they can really start with the model-based approach and the provided reference architecture rather than really starting from scratch. And then many other for us, it's today we will focus on business transportation planning, on sustainability, ecosystem sustainability. That there were a few that I identified are related to the research that we're going to show. There are some specific use cases that are related to, for example, Department of War in the United States, or the not necessarily probably just that, but in general, different MODs in the different countries. That is more specific towards defense, but there are a lot of use cases that are applicable to any kind of industry. So when we speak about UAF, we always highlight that it's transformational approach. So really how UAF is designed and what kind of concept it has, it takes in account the drivers for change, and then it changed the enterprise portfolio from the current one to the future one, and delivers some kind of strategic outcomes. So this is really the big picture of how we see it. And this is exactly what we wanted to show in the research that I'm going to present. The UAF as a whole, as it covers so many different use cases, it provides quite a lot of views and viewpoints. Overall, what you see in the screen, I always say it reminds me of the periodic table of elements. And it truly is something like that, because if we want to solve one of those problems that I showed you before, we don't need the entire grid. We just need to take some of the elements from the grid. It's exactly what we do in chemistry. We don't produce the material out of all the elements available in the periodic table of elements, but we just pick the right ones, the ones that we actually need. It's the same what we're gonna do here. We just pick some of the views that we need for the specific problem solving. And so these are exactly the questions that we try to answer. Where do we start? Which views do we need? How are these views related together? These are very common questions by the architects. And there is no single answer, because it really depends on what we're trying to solve. Nevertheless, there is a kind of principal schematics that simplifies the periodic table of elements into couple of core viewpoints and their interrelationship. So first of all, strategy. Why do we do it? Then the operational scenarios, what do we need to do? And finally, the resource scenarios is how we're going to do it and who's going to do it when we speak about human resources. And obviously, we can have a trade-off between different resource configurations and run some analysis, run some execution thanks to the model-based environments and answer the questions, which resource configuration is the best for the specific operational scenario to solve our problem and address our strategic goals. There is, of course, evolution behind it. So then we can have as is model of our enterprise, then we can have to be model of our enterprise. But then the thing is that what is to be when it's implemented, it becomes as is. And this way we're actually going circles and circles, improving our enterprise. This is a slightly different from the systems engineering. And again, it's more like a philosophical argument that we can have. But when it comes to the enterprise, its outcomes are changing every day. The enterprise itself, again, it's changing every day. It's not the same on the system side. Yes, we can have system evolving over the time, and that's quite a new concept because the old systems, you just buy them and they never change during their life cycle. They keep producing the same outcome. Now, of course, with the software intensive systems, we update them, we upgrade, and so we can inject some new behaviors. We can change the outcomes, but that is not happening as frequently as with an enterprise, and it's easier to manage compared to some enterprise where we have thousands of people delivering some kind of output every day. So it is important for us to have some kind of points in the timeline where we can measure some of the goals, some of the outcomes that we achieve. This is a little bit of theory. Now let's jump towards the practical application, and this will demonstrate a little bit of how the unified architecture framework can be applied to the specific problem solving. So we take the huge grid, we slice it down to just the things we actually needed for enterprise transformation planning. And we end up with something like this. So first of all is the strategy, of course, is the most important. So what are the drivers for change? What are the challenges? And what are the opportunities that comes out of those challenges and how they impact our capabilities? So the second step is really on the capabilities and capability development planning. Then when we know what kind of capabilities we need to achieve, we need to deploy, then the question is what we need to do, right? This is where we go to the operational scenarios. We develop as-is architecture. Then we develop the as-is architecture for the resources, so who and how we're going to develop implement these operational scenarios, and then we go to the to-be architecture, and then we define what we want to change. So how we're going to transform from the as-is to the to-be, and as I mentioned, it can go further and further and further, and transformation can actually be endless. Depends really on the situation and what we want to achieve. The last step is to really define the project portfolio, because when we build the architecture, we clearly know what we need to change, and this will bring us to the project management and the new projects in the organization that will help us to implement the change. Hiring people, teaching people, deploying new infrastructure, acquiring new systems, and so on and so forth. Then, of course, we're going back, and you will see that what model gives us is the traceability from when we go down to the projects, and as soon as the projects are completed, we can go back and check if our capabilities are now in place. So when we go to our specific use case, we will speak about transforming the bus fleet from a hybrid to fully electrical in the fictional city of Elm Springs. That's the name we come up with. And we will demonstrate. We will show what are the drivers for the change, and how we're going to model and really propose the change on some of the, first of all, identify capabilities, and then what systems we need to acquire or develop, and people we need to train or hire to be able to achieve the transformation we're looking for. So as I showed you the process steps a little bit in the previous slides, first step is to identify the drivers and challenges. It's really the strategic analysis we need to do before we go into a more detailed description of a change. So why do we need transformation? What are the drivers for change? What are the challenges that these drivers present, and what are the opportunities that that these challenges brings us? So we model drivers. For example, there is, as you can see, there is economic benefits driver, which presents some challenges if we want to go fully electrical. So right, first of all, it's a high initial cost because electric vehicles are more expensive. We need to purchase them upfront, and that's additional cost. And of course, another challenge, as an example, can be limited vehicle options, because not necessarily the next day we need them, we can get them, because the supply of electric vehicles and electric buses is not as high as for the hybrid internal combustion engine or internal combustion engine vehicles. However, these challenges, they also bring some opportunities that, okay, it's high on initial cost, but it can be lower on the operating cost in the future. So we need to consider that. Also, the technological innovation that we can get, like for limited vehicle options, we can also consider some mixed fleet strategies, and consider having a different the buses produced by the different manufacturers. That, of course, can again bring some challenges in the way we maintain them, the way we charge them. But this is for the trade-off that we can do when we go down to the resources layer. And then we produce the map of the different drivers. So I presented the previous driver, which is economic benefits, but then we have different drivers like energy efficiency, environmental concerns, government incentives, noise pollution reduction, the regulatory pressures, resource conservation, technological advances. And so we study all of those drivers with what are the challenges and what are the opportunities. Then finally, opportunities impact our capabilities. So this is where we either need to upgrade our capabilities, or we need to deploy the new ones. So the next step in the process, once we do the strategic analysis and we already define some capabilities, we need to plan on the capability increment and the capability deployment. That's the next step, and this is where we use the term of enterprise phases. So this is where we say, okay, the phase one is the hybrid fuel phase, as you can see on the time chart. When then the next phase is the fully electric phase, and we need to go from the hybrid fuel to the fully electric. Then we also introduced the third one. We didn't analyze it in the details and don't present it in the details in this research. But this is where we go electric and fully electric and fully autonomous, right? That's the third one, because then we have another dimension which is autonomous cars, and this is buses, and this is where we need to do again have a new capabilities and transform our enterprise towards it. And then there are, of course, transition phases because, well, we need somehow to get from there to here. Transition phase, again, needs a different capabilities, need to do a lot of studies, need to do a lot of analysis, the acquisition of the systems to really be able to get to the fully electric. So we also identify the transition phase in between. Now, when we have those phases identified, we look into what are the goals for every phase. So first of all, the high-level goals, then we go down, drill down to the objectives, and this way when we define the goals and objectives, we really define the motivation, and we're able to verify against the objectives when we go further down and really observe some of the different options that are available. So the high-level goals that are displayed here can really go into more precise, clear objectives that we can verify by running some analysis on the model. Then the capabilities, of course, and this is where we assign also capabilities to the different phases. So we say that these capabilities are available, like, for example, electric bus transport capability will only be available in the fully electric phase. And in addition to all that the hybrid phase has, it's not shown here, but it is depicted in the study and in the model. In addition to what's there, we identify that we need the 3 new capabilities, such as recharging management, electric bus storage and maintenance, and the charging infrastructure. So these are the core new capabilities. Yes, we're going to need some increment on other capabilities, like, for example, maintenance, because, okay, the maintenance of electric buses is different than the maintenance on the hybrid buses. But the capability is still there. It's the maintenance. It's just that it's going to change. It's going to be modified. But these 3 are completely new ones that we identified and that we need to implement for us to be able to switch from the current phase to the future phase. And there are some things from also capabilities for the transition phase, such as public awareness education. So we need to make sure that the people, the citizens of the city are actually happy about the change, that they know and understand why do we need it. We need a charging strategy. We need testing and pilot programs, infrastructure deployment, data analytics, of course, it follows because we need to make some decisions, infrastructure planning, supply chain procurement, we need to acquire buses, right? And then we also need to run some feasibility assessment if it's really the right way to go to achieve our objectives. So then when we define our strategy, the next step is to go and define the architecture for it. We start from capturing as-is architecture, or the baseline architecture, in other words. So we start from the operational architecture, then we go into personnel and the resources. So first of all, operational architecture, the purpose of it is to really have that solution independent layer, so that to be able to run multiple trade-offs on finding the best solution. Because if we don't have it, we cannot run the really different trade-offs and be able to do the trade-off analysis, understanding which resource configuration better suits our operational scenarios. So this layer is really important. It's important for whether you model enterprise, whether you model mission, whether you model some kind of program, to really be able to justify the right resource configuration, not the right, I would say, but the best resource configuration that is available there. So we model that solution independent layer, and then when we go to the resource architectures, then we already identify those different possible alternatives, naming the resources, naming the systems that we're going to use for the specific purpose, for the specific task. So operational scenarios are modeled, first of all, with the structural perspective. So we identify really what are the different, what we called here operational scenarios, such as, for example, respond to the traffic accident or perform medical emergency response. Is that really going to change what we are having today? And if we change it and we go full electrical, is the response to traffic accidents still going to be exactly the same? Well, probably. But then when we go to autonomous on the third phase, it will probably change. So then, one by one, those different operational scenarios need to be analyzed. So we go into more details, identify different players, different actors, interactions between them, and scenarios using the activity type of diagrams. So that's here for the hybrid fuel phase as we analyze the as-is operational scenarios. Also, then on the personnel side, on the human resources side, we analyze what is the organization today, how many approximately drivers we have, what are the roles that we have, and look into the overall organization, and more from the role perspective, right? So we're not looking to the actual people, Bob or Ron or John, in this specific diagram, but we look into what are the roles and how many of them approximately is needed to operate the bus enterprise, city bus enterprise today. This is where we describe who is really implementing those operational scenarios. But then together with the human resources, we have other kinds of resources. So we have facilities, we have different systems. We have, for example, as you can see, fueling stations, the diesel bus fleet, which then is detailed with the different types of buses. On the buses operation side, as you can see now, in the white color, you can see the human resources that I showed in the previous picture. And now in the orange, you see the different systems and software and hardware that is currently in the city bus enterprise. And only when we know what we have today, we can offer how it should look tomorrow. So this is the necessary step really to capture the organization today. But then the next step is to really go to the future, and this is really what we need to do to achieve our objectives and go fully electrical at the specified date. That's again a little bit a reminder of the process. So we go to define, first of all, we define to be operational architectures. Then we go and define the personnel and resource architectures, and we run trade-offs, right? So that we can choose the best possible configurations to address our operational scenarios. So on the to be for the fully electrical phase, again, the same way we model operational scenarios. We identify the new ones, for example, charge electric bus, how it's going to happen. There are multiple strategies, and we need to really find the best one, because we can charge at every bus station. We can charge just at the end station. Or maybe we can charge, we can implement something as the electromagnetic rail, or look for some other options that charge on the go. So there are different options, and we need to consider all those different strategies. Then we map operational scenarios to the capabilities. So, for example, as you can see, those three newly identified, such as recharging management, electric bus storage maintenance, and charging infrastructure. So we map those different operational scenarios to capabilities. So for the traceability, that we can easily navigate from the capability to the suggested operational scenarios, and then even navigate down to the proposed resource configurations to implement those operational scenarios. So now on the personnel side, on the human resources side, we do some modifications. The difference here that when we speak about operational, maybe it's not always achievable, but really the proposal is that for the to-be phase, the operational scenarios need to be carefully updated, and sometimes even better to define operational scenarios, not looking to the past, not looking to what we currently have on what we had in the future, in the past, just because we over constrain ourselves. We look to what's there, and we cannot propose something better. Where on the resources side, we always say, okay, look back to where we are in the current resource configuration, and then propose changes based on the operational scenarios. We really need it because, you know, there is definitely too much effort to remodel it every time. The resource models are huge, and this is really what we have today. So we want to show from what we have today how we go to what we want to have tomorrow, and how much it will cost to do the impact analysis, etc. So we really have this tie to the current resources, and this example here demonstrates some of the changes. So we really get rid of some of the things here, and we introduce some of the new things. So, for example, we get rid of the trolley bus dispatch and diesel bus dispatch departments, and we say that it's zero, right? It becomes zero in the new phase, and this is where we introduce the new electric bus dispatch department. The same on the maintenance, right? So electric bus maintenance department replaces the hybrid bus maintenance department. And then we introduce some completely new roles and organizations departments, such as charging infrastructure department with the manager, with the charging infrastructure installer. So these are the new roles that we need to introduce. And the same on the resources side. So we need to deploy charging stations. We need to deploy a new software, which is here called Electric Bus Operation Optimization, where we really need to take in account the charging, and we really need to make sure that the buses gets charged enough to go from the one destination to the other, and at the same time also ensure that we meet the schedule, right? Okay, and then we map back to the capabilities. So this is where we can say that these newly identified resources, they really serve towards the new capabilities that we identified, such as electric bus transport. Okay, we need service configuration for it. That's the big one. But then we have smaller capabilities. So we need recharge management. We need electric bus storage maintenance, charging infrastructure. So we map back capability configurations on the resources side, with all the resources and people that compose them to the capability. So basically, we create kind of the packages that we call capability configurations that groups all the resources that we need for the specific capabilities to be deployed. And finally, when we identify what are those new resources, we go to the projects, to the project planning, how we are going to implement them. And when we come to the projects here, we say that the projects, they deliver capabilities, right? It's not the resources, it's the projects. But this is not direct, because first of all, we need projects to deliver systems. And then when we deliver systems, those systems, they, what we say, exhibit capability. So as you see, it's a dashed relationship. It's not direct relationship, but there is relationship between project and capability, because project delivers resources, and resources then they exhibit the capability. The milestone is really the point it's the point at which the resource is delivered and the capability becomes available. And as you can see, it's the human resource and also the system resource shown here, that together are combined in the capability configuration to exhibit the capability. So what do we do here? For the projects, we model the project portfolio. On the enterprise architecture side, we don't need to manage projects. It's the project management. It's the different tools. It's the different skills. What we need to do is just to define the project portfolio and hand it over to the project managers and to the people responsible to implement them. But what we do here is we really say, okay, so that there are a couple of things we need to do. So we need to do a power supply upgrade. We need to install charging stations. We need to maintain charging stations, and we need to recruit and train the new personnel that we need for maintaining the charging stations and really maintaining the buses and etc. So now when we map these projects to the deliverables, we see that, for example, power supply upgrade, it needs to deliver power supply resource. We see just the big configuration. So there is a lot of underneath that I've been showing you before. So we can go into the smaller project tasks and say which one delivers what. But that is more on the project management side. Then for the charging station installation, we see it delivers the charging stations, and then for the personnel, we deliver the new roles. The new roles with the trained personnel so that we actually get what we need for the capability to be deployed. In this case, charging infrastructure managers, charging technician, and charging infrastructure installer. And overall, these all smaller projects are combined into one bigger project as a part of the overall portfolio. And this is where the charging infrastructure capability configuration that is combined, as you can see, is composed of everything else here, of all the other resources, needs to be available for the capability to be available on time. And on the yellow, you can see the phase. So we can see where our initial plan, where it actually starts and when it actually ends. So at the end of the transition to electric transportation enterprise phase, we should have all those capabilities available. Now, when we go on the capability portfolio, it's again the timeline, but it's slightly different timeline, because this is where we don't look into the projects, but we look into the capabilities. And the capabilities are here related to the project. So if our project plan says that the electric bus storage will be available at the end of the 2029, this is where we can see that our capability it becomes available. We don't have this capability before. Some of the other, they are upgraded. So for example, bus operations to electric bus operations. So we see we had it, we just upgrade it. Some remain exactly the same, such as emergency support, but some are completely new. And this is where on our plan for the people that need to understand the planning, based on the project plan, they can actually see when the capabilities are going to be deployed. Of course, the projects can get late. And they usually get late, and there's some issues, budgeting, etc. That is something that delays our capability deployment, and it's something that we can see in our capability roadmap. So overall, then, we go down from the strategy to the projects, and then go up from the projects to the strategy to be able to verify our planning. and see if our transformation planning is correct. Again, the similar view as I showed you before, and in this case, as you can see also in yellow, we show that there is the fully electric transportation phase, and by this date, we need to have all of the capabilities that we identify available. They're tested, they're deployed, and then we can say, okay, we achieved our strategic goals, and we move towards fully electrical. But in case some projects get delayed and we're not there, so then we need to analyze and update our planning. And again, there is a relationship with the project plan, and any update on the project plan really is propagated towards the capability deployment map. So at the end, for this study, as I mentioned before, we just picked some of the views. So this slide shows which of the views were actually used. It depicts also a little bit of the project structure, of the model structure on the modeling environment. As you can see, there are a lot of views that we didn't use for the specific scenario, and at the end, it really simplifies the application of the unified architecture framework. So let me jump to the summary. I see that the time is really running fast. So this approach has been documented in a couple of sources. First of all, we published the book. So we put it in the book. You can get the digital copy for free if you scan the QR code or follow the link that is provided here below. Yeah, you know, QR codes, they sometimes get expire, or, you know, just in case something happens with it, I just put the link. And you can download the guide, the detailed guide explaining step by step the approach that I presented to you. Of the limited time, I of course skipped some of the steps, but if you go to the book, you'll see it all laid out and explained. And also this approach we published as the INCOSY paper last year in 2025. It has been presented in Canada in INCOSY Symposium. So there is also the paper available, and if you want to get the paper, please reach out to me, and I will send it to you along with other related works if you're interested. So based on this study, we also did another publication where we showed how we can execute the model. So we demonstrated a little bit of applying the SysML parametrics, behavior simulation, Monte Carlo simulation, on really performing some analysis on the different charging stations. Of course, it can be expanded because we can do trade-off on the buses. We can do trade-off on in general the approach of how we're going to charge the buses. And so on and so forth. So there are really a lot of areas for the trade-off, but this demonstrates just one of them. One more study related to sustainability that we published 2 years ago with our partners from SE Studio is the what we call the systems of systems, global solutions to global problems using UAF. So it's different. It's not related to the study I presented today, but it's related to sustainability. So it really talks about the global copper market. And this is where we did the extensive strategic kind of analysis on what are the drivers for different enterprises in the global copper market to go towards more reusability, recycling of copper, rather than really extracting more and more of it and raising its price in the global market. So you can have a look to it. This is kind of an interesting study. Not so much maybe on the modeling. and as I showed you today, it was really heavy in modeling, but on this study, it's also really about more about the strategic drivers and challenges rather than modeling the full UAF scope. A few more related things that studies that has been presented in some of the events and are publicly available, and I put the video links in, such as, for example, electric roads in Sweden. It's quite an interesting study. Again, the trade-off between the three possibilities of wire charging, the rail induction charging. So there are three possibilities of doing the charging on the trucks, and it's the project that's run by the Swedish government and multiple universities and consulting companies involved to understand which one is the most efficient to implement their vision, which is to implement electric roads by 2035. Another study on the farming, again, sustainability related. As you can see, I only pick things that are related towards sustainability, is coming from the John Deere. Again, it's publicly available. I put the link, the YouTube link here, so you can listen to the John Deere and the way they apply a model-based approach and UAF towards sustainable smart farming. Demonstrating how the different systems work together towards increasing the sustainability of the farm. Now, for the more studies, again, a little bit of the promo. Apologies for that, but it's just the good place to do it. If you're interested to see more studies on the enterprise architecture framework applicabilities, then please join the UAF Summit, which is OMG, or Object Management Group, or organized event we're running every March in Reston, but it's hybrid event, so there's possibility to join remotely. And we're going to have some interesting studies here as well. Interesting presentations. Some might be sustainability related. We're now in selection of the abstract, so I cannot reveal you where we are and what presentations we're going to have this year before the time we publish the full program. Finally, for those who are interested in model-based approaches, please join UAF community on LinkedIn. This is where we exchange the information. Also, you can join the SWS systems community for modelers, where we also exchange the information, where we answer the questions to our users. So in case you're the user of CATIA modeler, the Cameo modeler, or Magic Draw, ever, you can really go there and collaborate with the other users. And that's it from my side. I think my time is up, unless you tell me that I still have a few minutes. So I also could really run you quickly through the model.
All
Thank you very
right.
much for listening.
Yeah, thank you very much, Aurelius. That was very interesting. So we had a lot of people also cheering your presentation. Maybe a round of applause first. Yeah, some had to leave, but we got some questions here. I would suggest that we go first through the questions from the ones who are still here. You can just raise your hand and ask the question, and then we can go through them. And yeah, I also have a lot of questions, so yeah. Okay, there is already one from Adriana.
Oh, yes, it's great. Great presentation. But my question is that all you've done is, and I'm sorry, I'm not trying to denigrate this great work, but all you've done is change the energy systems for a bus. The actual architecture of public transport system hasn't changed. All you've changed is the energy that drives the buses. So public transport systems have been operating in some countries for 100 years. So they're very well, there's a lot of work that goes into planning and implementing and managing public transport systems. And so whereas the energy is the critical part, putting in, charging stations and things like that. So my question is, though, that I'm changing the energy system doesn't automatically give you sustainability. And so my question is, within some of the planning diagrams or the architecture diagrams that you use, how granular or where I mean, I could see many areas where you can begin to integrate the sustainability principles, and in particular, my field of expertise, circular economy. I mean, is this where is this considered? Because it hasn't been clearly indicated in your presentation. Does it get, how granular do you get within the architecture that you have to really promote or implement real sustainability programs or circular economy programs? That's my question. So
it's a very good question. Thank you very much. First of all, there are a couple of things. First, when we started this study, we were not really focused on the sustainability. Really, our idea was to demonstrate the transformation and how we can apply architecture for the transformation, which can be of any sort. For example, right, digital transformation. And then we come up with this example that, okay, maybe we can show that we just change, as you say, that the energy, right, on the energy side, the buses. But also, the other thing is that we really needed to scope, because the scope was already big. There are many areas to expand, but at this point, we just thought to limit the scope. And then the third thing is that none of us were sustainability experts. And as I said, this was not the primary focus. So we didn't really look into it at the granularity perhaps you would have expected. But at the same time, I see a lot of possibilities to really expand and with some expertise that you have in the sustainability working group, perhaps include those sustainability metrics or sustainability analysis into the model, and really expand on this problem that has been
I mean, and it would be a great project. I mean, as a case study to work on that goes beyond just the transition from one energy source to another, to talk about how granular you need to get in regards to a sustainable bus system, rather than just a energy transition energy system. So I'm not trying, I mean, I know perhaps I'm maybe sounding very I mean, I'm not trying to be condescending in your work. I'm not saying that. I'm just trying to get a feel for my first.
Adriana, maybe I can just chime in for a second. So we do have other groups who are working on things, and what you're looking for would be more something like ARFIS did, and we have a couple of members who have been present before from ARFIS as well, and Aurelijus through the French chapter of ECOSI is also part of that. They have done a mobility study, which is really worth your interest. It's in French for now. I don't know whether you speak French, which really addresses a lot of those things you're getting at. So for us right here today, I think the important thing is that we are looking at the UAF, which is a new approach, and which Aurelius really introduced us to, which was really fantastic. And we have quite a few experts here who are expert modelers, who at the same time are also sustainability experts. And so this is, I think, a starting point for us to look how this capability approach can be added to our current endeavors, and there are many ongoing, and Hamza will introduce you to all the other things we have ongoing as well.
Great, thank you, Casey.
Yeah, that's what I wanted to add. So actually, in this webinar series, we invite people from outside of our working group to bring their knowledge and expertise, and then we apply it to sustainability. So Aurelius here is an expert in UAF, and the things that you have mentioned are the things that we will work on in our sustainability working group, and perhaps Aurelius will have time to also, or we can collaborate with their working group to apply UAF for our case study where we are looking into circular economy and all these topics.
I think it would be a great idea, and I hope that our group would be really interested, because I think that sustainability working group is really one of those working groups where I think we could really find some kind of common grounds, really to do some kind of a common projects.
Yeah, absolutely.
Yeah, it's already like gathering many working groups together. So I think it's a very holistic topic that's bringing many working groups from the INCOSI and also from the outside world. Kai, do you still have a question, or is it your hand from before? Kai, you're muted. Okay. Does anyone have another question? Okay, then I have some questions, and actually it's something that we are working on. So you have like this enterprise transformation. So especially, well, maybe let me show you some slides also.
Okay.
I think it's also like for Adrian to also have an overview of actually what we are doing in the working group. Okay.
So Bruce, do you want to comment on what you see with respect to the integration for LCA whilst Hamza is bringing this up? Let's to share your screen, Hamza, because Bruce made a comment in the...
Okay.
So you can bring this up. Bruce, you're still there?
Yep, all that is the life cycle analysis that we've been talking about, and that would be nice to see included in the model.
Yeah. Okay, then I would share my screen and show you a little bit of what we do. Okay, so within the sustainability working group, we have actually two parallel bi-weeklies. One on Monday that is focused on the project Sustainable Together. And here we are showing how we are addressing sustainability like holistically and showing how to transform from a conventional business and products into sustainable ones. So, and we say if we want to do it like properly, you need to start with the mission and the vision. Then you look into your business model, and then from your business model, you do, of course, your financial model. You see, look, the cost structure and revenues. And when you change that, you change then the enterprise architecture, and then, of course, your system or product that you are selling or services. And yeah, then you need to consider the enabling systems. And let me get the pointer. So you need to consider the enabling systems and then the life cycle stages, and then come the use stage, and then the circular economy strategies. And these are all like the technical cycle, and we're also looking at the biological cycle. So yeah, and there are some topics that are throughout the life cycle, like systems thinking, digital engineering, life cycle assessments, and all these assessment things, and risk analysis. So my question to you is, so in this transformation, before we go into the enterprise architecture, we look at the business model. So this is like more the, I don't know if are you familiar with the business model canvas?
Yeah.
Okay, then we try to look, so what is the new value that the company is bringing to which customers, and how are you delivering the value, and how are you capturing the value, and so on. And for me, the question, like, is there an integration between the business model and the enterprise architecture? Or
there are definitely
UAF?
Yeah, there's definitely a lot of common grounds, and this is the topic that has been brought many times into the UAF development group, and we implemented some of the concepts as we've been asked by our user community, such as, for example, value streams. And we go. There is the agile framework on the value streams that we've been looking to and been working with the business architecture team. That also a part of the business architecture guild. I don't know if you came across that term, but so we work together on implementing those concepts such as value stream, operational value streams, development value streams, value in general, and how we create value. So it's not fully, I would say, not all the concepts are really covered in UAF, like one-to-one, like an object in the canvas, in the business canvas, does not directly translate sometimes to the UAF element. But overall, when you look into the holistically, I think that at the end, UAF covers those concepts and can be mapped, maybe not one-to-one all the time, but can be mapped to the business canvas.
Okay, cool. Yeah, but maybe if you can send me some work on that, or if you want. So we're actually working on a paper to really map the business model canvas. Like, we want to have this information, the business model canvas, flow into the enterprise architecture model, and then later on the product or system model. Yeah, if you want to, you're interested in contributing to that, so we are really looking to this one-to-one mapping, and then later on also like a tool integration and so on. And
this is definitely interesting area, and as this is fairly new to UAF, we haven't done a lot of we don't have a lot of good examples, so maybe it's also would be a good opportunity for us to build something on.
Yeah, so actually, Anthony Upward, who was here at the beginning, so he's the developer of the flourishing business model canvas. So he extended the traditional business model canvas from Osterwalder, including like the environmental and the social perspective. And he's also involved there. So we have people from the economical perspective, economical schools who are there. So I think it will be pretty good to look at that. And also the next question, how. So here you looked at the transformation from a company that's changing their fleet. So what about when you have, for example, now the automobile industry used to sell fossil fuel cars. Now they have to sell electric cars and also maybe circular cars and so on. So how do you integrate with the product development and enterprise architecture? Do you also have some work there?
Again, great question. In this particular example, no, we didn't really look into it, but obviously there is relationship, and the first thing that comes to my mind is, for example, the work done by German the German chapter on the ISO 15288 processes. I think it's kind of generic template of how you actually map your operational environment to the objectives and to the ISO 15288 processes. Could be at the starting point, but then I think that it's really a very common use case in defense.
Mm-hmm.
Okay, maybe it's not entirely the most sustainable industry in the world, but this relationship between the product development and the strategy is really something that they really look to, and there are some There are some presentations. I'm referring to one by Airbus, which was quite interesting, and I think it's also available. I would need to double check, but really aligning the roadmap. So there is the roadmap from the Ministry of Defense, which really says, okay, these are the capabilities we have to have by that specific date and time. Then Airbus is the main supplier, they are OEM. And Airbus is providing this capability, providing systems to support this capability. They have their own roadmap on when they're going to develop systems. Then every supplier, a first-year supplier, for example, that works with Airbus, they have their own roadmaps. But the Airbus as the main OEM, they really need to control and align all those different roadmaps because they are the ones to deliver at the end. And this was a little bit related to what I showed here about, on the planning, on the capability development roadmaps, on the technology roadmap. That's more in the real perspective on how they apply it to when they develop their systems. So that was kind of interesting to see how everything ties together. And really the production and the delivery of the different resources ties to the capabilities of the country and Ministry of Defense.
Yeah. Cool. Yeah, Kai, you had the hand up the whole time?
Yes. So apologies for taking us way back to the beginning of your talk. And I think what you just said, there is plenty on this call, starting with Bruce, who really are exactly looking at what you described. And so it's been really interesting. It's been part of the discussions since we started to work on that paper, which Hamza mentioned. I wanted to quote Anthony because I promised him, and then I'd like to also maybe ask a question which hopefully helps people like me and others on the call who are not entirely familiar with model-based systems engineering, and just to connect the dots for us a little bit here. So my first question then is that I'm quoting Anthony, who was looking for a connection to ecology in the initial socio-technical systems definition. Maybe Hamza, you would like to chime in as well, because and that might help Ariana as well to understand what our endeavors are, where we're going, and how we try to connect it to ecological, let's say, or to extend that definition in a way. Maybe so that's the first part. Do you want to chime in, Hamza, or
Yeah, sorry.
Aurelijus?
So, yeah, what was
because
what was the question again?
Anthony, very early on when you presented us all those definitions, quipped about the lack of having ecology and that it should be socio-technical and ecological. And I think that's we've been for the first time mentioning or getting that notion out, I guess, Hamza, last week in a way, in a starting point.
That's a good point. That's a very interesting point. And it's very timely because as now we just started working on the enterprise systems engineering primer, this is where we're planning to review and update the definitions that exist today and provide some kind of high level overview terminology for our users. At the same time, updating the CBOC as well, because there are some pages on the CBOC, but they haven't been updated for 11 years.
Yeah, I think also so you will be at the IW. So there is this joint working group projects. I don't know if you heard about it, and I think so. There is a move more towards this, not only socio-technical but also environmental or ecological systems. So seeing the natural systems as part of the system. So not only as a stakeholder. I mean, as a stakeholder with their needs and all these things. Yeah, and not only like a resource that we use. Yeah, I'm not so I will not be at the IW, so perhaps it's also a good chance to approach this topic. I think otherwise from our side, I will definitely get in touch with you to regarding the paper. So we are starting with just a first concept on how to map the business model perspective, because especially the business model is a very, very important aspect in this transformation, especially in sustainability. So for companies who are in this traditional or conventional way or need to become sustainable, so they need to have an economical benefit also in doing that. And this business model, doing the costs and revenue analysis is one of the important things. And the thing is that we learned that the business model is also getting very kind of complex. So it's not anymore only one company who is doing a business model, but you have the ecosystem. So in the circular economy, you have an ecosystem of companies who need to have shared business model. So, and I think like this enterprise architecture is going to be like very interesting, as you mentioned, like to align this system with the yeah.
I think this sorry, I'm not sharing, but the one of the on the slide 48, I show the there is the study that we did on a copper market, the global copper market, and I think this is again quite interesting study because it seems that from the recycling and from everybody gains except the extractor, right? But then what could be the driver for extractor to stop extracting, right?
Yeah.
And or to reduce extracting. That's really the big challenge because well, it's a business and they definitely don't want to stop.
Yeah.
No,
Or if you
sorry
Yeah, go on.
to interrupt. I think that copper is integrated into many products. And so really the mining industry, which is the extractive services that you're really talking about, there is growing evidence over a number of years now that urban mining is proving to be a lot more profitable. So unfortunately, it hasn't been scalable. Mining industries are used to working in millions of tons, not working in hundreds of tons. So their idea of urban mining has a very different metric. And so that's why they haven't necessarily been interested in it. But there's a whole range of reasons why that's changing. So, and they have the expertise. So I think that there's a growing shift that urban mining will become part of a mining company's capability.
Yeah, the other issue there is also that the supply chains are not set up and they take so long to transform. So we do have the amount of in inverted commas reclaimed ores, and but we cannot get into the place. Randall, just sorry, a second before we move to your question or something, and another comment, just maybe to also help Ari and myself, and well, now there are not many others there anymore, but to make the point of Anthony also, and he hasn't been here long enough, and I think he sort of flies in and out. That doesn't always help. Make the comment about waterfall structure. It's what he saw in the beginning in your sort of diagrams. Am I right to interpret model-based systems engineering as an approach which would allow us to have that flexibility which we usually out of the software industry look for in Agile? That's my interpretation of it, because I can then update the model in inverted commas on the fly. Might not be as easy as that, but we agree, and I see a couple of nods there, that what we gain by applying that across our current systems, which are not only software-based, is we want to reach this flexibility there for adaptability purposes or something. So Aurelius, question to you.
Yeah. I mean, I'm fully.
Am I dreaming?
No, I fully agree. Definitely, there are a lot of values, but also it's important how it's done, and over modeling it can be inefficient as well.
Yeah.
So it's really it is always tough question, how deep we need to go, how granular we need to go, and we really need to apply it carefully.
Yeah. Randall, you have a question.
Yeah, I thought the point about Adriana's point about scale was interesting, and also I think Aurelius was discussion about what was it, the copper mining.
hopefully this isn't too off track, but it's sort of an interesting situation with sort of circular economy concepts, because it's sort of underappreciated that trying to develop a new material stream is connected to how the existing material extraction and development and product system is constructed, in that it affects the economics of all that, right? So if and I'm not defending it, I'm just saying that it's a nuance that's often underappreciated, because by extracting more resource from, say, waste, can actually create unintended consequences in terms of the availability of the material. What you need to look at is, I guess, the part of it is the not just the price, but also the extraction logics.
But if I apply what I just saw from Aurelijus, there is tremendous interesting stuff there with respect to the capabilities and the timing and when they're available. So I'm excited for it, to see it to be applied to exactly that problem, actually, Randall, with what you've just been defining. And I know it from a couple of startups also in supply chain, where the problem is making sure that you have the availability where you are. So it's really the restructuring of the supply chain with respect to that. So, and we're only at the beginning of a lot of this. So the other, and I'm making that because we've been talking about biomaterials, which sort of goes into the same direction, Hamza, that would be sort of on the same plane, right? The difficulties to either start experimenting with them. So there's the whole compliance stuff on whatever, security and whatever. And on the other hand, then, make sure that you have it available in the amounts when you need it. So,
right. Can I just, sorry, I have to go because it's 1:30 in the morning and my bed is calling me. I've got a busy day tomorrow. But I do want to add one comment to Randall, is that as a newbie to these meetings, and not too cozy, but as a newbie to these meetings, and over time you will get used to this, is that I don't talk in terms of waste. I talk in terms of material management, and that we are going to need to transition from waste management to material management. And that's the game changer. It's not supply chains. Supply chains are only the arteries. If you can't manage your materials, it doesn't matter how efficient your arteries are, how efficient your supply chain is. It won't make any difference. So material management is really where we need to be.
Fantastic. So both Randall and I are part of the Natural Systems Working Group initially as well. And we have looked at biomaterials at some point. So I think there's tons which should be sort of connected there. And there is New Materials Working Group. Are you aware of that at Incosi as well, which might be really interesting?
No, I'm not aware of it. I didn't even know. Okay. I mean, I got the list, of course. There's a list of what members, and, there's only so much I can attend, because I'm involved in other things as well as rebuilding my small company. But of course, to me, it's not about biomaterials. It's about materials per se, because biomaterials also, the applications for biomaterials still has its limits. We do have physics. There's this thing called physics that limits everything. That is really that we have to bow down to. Yeah. So,
before you leave, I just wanted to also let you know that I have the link to the mobility study there. It's in French. I don't know whether you can handle it.
Yeah, I looked at it and I came to get it translated to English. Unfortunately, the documents are. But anyway, I'll take a look at it. But anyway, I'm glad to be here. Fantastic presentation. I really enjoyed it. I'm looking forward to getting the presentation and becoming actively involved in this and other working groups in INCOSI.
Thank you very much,
Thank you
Adriana.
very much.
Thanks for joining
All
us
right.
so late.
Okay.
Ciao.
Bye.
Thank you all.
Yeah. Yeah, Aurelius, so I think we will be like closing the session as I mentioned. So I will reach out to you. I think it would be cool to start with this small paper with the concepts, and then we can build up on that. So actually, like Gautier Foni was motivated in the beginning. I think he got promoted and then he vanished. But he
No,
was
I can double check with him. Yeah.
yeah. But he was like very motivated actually to work on UAF and sustainability and so on. So yeah.
Okay.
So
Yeah,
we
it would be
will.
good that he's involved. Yeah, I think he was just more involved on other projects recently,
Yeah,
but
probably. Yeah. No, I think we are really like, as I've showed in that picture, we're really at the top, this integration between the business model, enterprise architecture, and systems engineering. And from there, we're gonna dive into like this all granularity and all these things. Okay,
perfect.
then thank you very much for joining us, giving us this talk. It was great to have you. Nice discussion. Thank you everyone for joining. And yeah, see you soon, I guess. And we keep in touch definitely.
Thank you
Okay.
all very much.
Thank you,
Have
everyone.
a great evening,
Ciao, ciao.
morning, whatever. Bye-bye.
So, Hamza, so I do schedule the second one for February as well.